This tutorial will illustrate how a model with complex geometry can be quickly generated and safe using its powerful drawing and drafting concepts. The floor plate that we will create will be 2 bay by 3 bay, with an edge curved along a 19-meter radius, with numerous openings, supported by columns and walls. The majority of the columns are offset from grid line intersections, and the axis of the column on the curved edge is oriented along the radius of the curve. The faces of the walls are flush with the edge of the slab. All columns are 325 millimeters square. Walls are 200 millimeters thick. Floor height is 3.5 meters. We will use a slab thickness of 250 millimeters. We start by going to the File, New Model command. For this example, we will set the database units to Newton millimeters and click on the Grid Only button. We're going to define all of the geometry directly, so we will not use any of the template buttons. We will have 4 grid lines in the X direction and 3 in the Y direction, with a spacing of 7.5 meters in the X and 9 meters in the Y. To verify the grid, click the Edit Grid button. We want the numbering of the Y grids to start at the top and to be on the left side. The model grid lines along with the horizon grid are now shown. The horizon grid is simply a visual aid for helping to lay out the model, much like engineering calculation paper. Currently, each square is 1 meter by 1 meter. We can turn off the horizon grid by going to the Set Display Options command and unchecking the horizon checkbox. Next, we will modify the default slab. We will change the thickness to 250 millimeters. Now we will define a column property by modifying the default column. We set the size to be 325 millimeters square. Similarly, we set the default wall thickness to 200 millimeters. Before we start to draw our model, we will check our snap options. Snaps control the placement of the mouse cursor when drawing, and the many different types of snaps that SAFE offers provides users much control and accuracy when placing objects. For this model, make sure that the snap to points, grid intersections, and intersections, as well as the intelligent snaps are checked. Intelligent snaps help when drawing beams and columns. Also make sure that the snap increments of metric and degree are checked. Snap increments snap the mouse to specific lengths and angles when drawing lines, such as the edges of slabs. Delete the 5 millimeter and 25 millimeter snap values as we do not need this fine a resolution, and likewise change the angle snap to 15. When the snap button is depressed, the options selected on this form are active. Now we are ready to start drawing the model. First, we'll draw the slab object. Click at grid A1 to start. Note how the line is dimensioned as we draw, and then click at A3 for the next corner. Continue and click at C3, and then utilizing the snap increments, go up at a 90-degree angle 3,000 millimeters. Continue with a horizontal line at a right angle out 7,500 millimeters, or the width of the bay. Next, switch the line drawing type to arc center and 2 points. The first point will be the end of the last line. Go back 19 meters to set the center of the curve, and then draw the curve until it intersects grid line 1, and click the mouse. Finish the slab by clicking again on A1, and then click the Select Object button to leave the draw mode. If we zoom in at C1, we can see that the slab edge is offset from the C grid line as desired. We will return to the full view to continue our model. Next, we will draw in our columns. We set the column height below equal to 3,600 millimeters. And click at B2. This is the only column that is centered on a grid. Next, we set the cardinal point to bottom left. And click on grid A3. The lower left corner of the column is located at the grid intersection. Set the cardinal point to bottom center and click at B3. And then bottom right and C3 and the corner point of the slab along the grid line D. Switch to top right and click C1. Next, we will draw the columns that are offset from the grids. Set the plan offset Y to minus 1,500 and the cardinal point to middle left, and click at A2. This draws a column 1,500 millimeters below where we clicked. Before we draw our next column, we will go back to our snap settings. So far, we have used the Snap to Points option, the Snap to Grid Intersection option, and the Snap to Intersection option. Now we will use the Intelligent Snap option, which is very useful to draw non-uniformly placed columns. We start by leaving the draw mode and going to the View Show Grids command. We are turning the grids off to show how you can still accurately draw columns without snapping to grids. Select the Draw Columns command and make sure both offsets are set to 0 and set the cardinal point to middle right. We are going to draw column C2. Notice how when we pass the cursor over any column, it automatically starts to dimension from that location. This is the intelligent snap. For the column at C2, we want it to be 7.5 meters over and 1.5 meters up from the middle column at B2. Also note that the program notifies us that we are aligned with another column line. We could continue to draw columns by simply measuring out from the last column drawn. Leave the draw mode and turn the grids back on. And note that the column just drawn is correctly positioned along the C grid line. Click the column button once again and set the plan offset X to 1,500 and the cardinal point to top center, and this time use the Snap to Grid option and click on B1. A column is drawn to the right 1,500 millimeters. Lastly, we will draw the column on the curved edge. We leave the column draw mode and select the Draw Line command. We draw a line horizontal from the column on grid line C across the slab edge. Where these intersect is the location of the column. Return to the Draw Column command and set the angle to 23 degrees. The cardinal point to middle right, and click when the snap says intersection. Leave the draw mode, select the horizontal line drawn as an aid, and hit delete. All columns are now drawn. Next, we will draw the walls. Start by zooming in to the top left corner of the model. Next, we will go back to the snap options and check the fine grid option. Set the fine grid spacing to 100 millimeters. The mouse will now snap to an underlying grid at 100 millimeter intervals. Click the Draw Walls command and set the wall height below to 3600 millimeters and the plan offset normal to -100 millimeters. And click at a point 100 millimeters in from the grid intersection and go out 2900 millimeters. What we drew was the center line of the wall, and note that it was located 100 millimeters below where we drew it. Draw the other wing of the wall using the same technique. And notice how they are connected at the corner. When we zoom out, the thickness of the walls is displayed. Now zoom into the other wall location. Draw the horizontal wall with a 100 millimeter offset. Remember, we are drawing the center line of the wall. Draw the vertical wings using no plan offset. Snap to the previously drawn wall endpoints and go vertically 1900 millimeters. Now we will draw the openings. Before we do, we will shut off the fine grid snap as it is no longer needed. Next, we select the Draw Rectangular Areas command and set the type of object to opening. Click on the left top corner and drag to the lower right corner. Now zoom around the C2 column to draw 2 additional openings. Select the Draw Rectangular Area command and snap to the point of the column axis and drag until you have a 3000 millimeter by 2500 millimeter opening. Leave the draw mode and select the opening and use the Edit Move command to shift the opening up and to the left by 500 millimeters. Choose the Draw Rectangular Area command once more, and this time snap to the top right corner of the previously drawn opening. Drag the mouse until an opening of 1500 millimeters square is drawn. Leave the draw mode and select the opening, and again use the Edit Move command to move the opening up by half a meter. Restore the full view and switch to a 3D view, and we can see the placement of the walls, openings, and columns. For a better view, we will adjust the transparency of the area objects and check the Extrude View option in the Set Display Options form. Thus, in a short time, you have seen how easy it is to create a model with complex geometry using the many drawing and drafting features of SAFE. This concludes this tutorial.